Hello, I'm Jo Fay, and this is a Swissinfo podcast. Swissinfo is the multilingual and international public media company of Switzerland. Every year, 30 billion tonnes of concrete are used worldwide. Cement production causes 8% of global greenhouse gas emissions. A Swiss company has found a way to capture CO2 and store it in recycled concrete. The Swiss firm Neustark has developed a method to turn concrete waste from demolished buildings and roads into a carbon sink. That's creating an environment that absorbs carbon dioxide from the atmosphere. Our science journalist Simon Bradley met Lisa Brown from Neustark earlier this year.
Hi Lisa.
Hi.
Hi, how are you?
Good, Thank you. What about you?
I'm fine, thanks. This is a special place. Where are we?
We are here at the wastewater treatment plant Bern.
What are these big tanks here?
These are anaerobic digesters that are digesting the bio-waste, so sewage sludge from the wastewater treatment, but also other biogenic waste such as food waste from restaurants and so on. So they are converting this waste into biogas. And biogas is essentially a mixture of methane and CO2. The ratio is approximately 60% of methane and 40% of CO2. What they do here in this large column is that they separate the methane from the CO2 to be able to inject the biomethane into the local gas grid. Biomethane is essentially the same as natural gas.
The CO2 used to be released into the atmosphere, but not anymore. It's now siphoned off and led through a compressor system to make it liquid, so it can be filled into tank trucks for transportation. We're now driving up to Biberist in Solothurn to have a look at one of the sites where the CO2 is stored in recycled concrete. We're making our way up a heap of concrete aggregate.
Great, this is a real adventure. So where are we? What is this place?
We are here at the old paper manufacturing facility that you see here in the back. And this facility is now teared down and the demolition waste ends up here to be then enriched with CO2.
Okay, so we're walking on concrete aggregate that has already gone through the process, or?
Yes, we are standing on a mountain of CO2 enriched concrete aggregate.
So where would this CO2 enriched concrete aggregate be used?
So some part of it is reused here on site. So for example, the building here, the base of the building was built with CO2 enriched recycling concrete, and a lot of the part is also used then in the surrounding for new buildings.
Okay, so it stores the CO2 permanently, but could the CO2 be released later at any time?
There are only two factors that could lead to a release of the CO2. One is heating up the material to over 900 degrees, which never happens in normal circumstances. Sure. And then the other one is putting acidic to the concrete, which is also not happening in normal circumstances. So in other words, even if we build a new building with the CO2 enriched concrete and this building is teared down in 50 to 100 years, the CO2 won't be released into the atmosphere. It's really stored durably.
I wanted to know how good this recycled concrete really is.
What are the special properties of this recycled concrete aggregate?
Maybe I should start beforehand by explaining what concrete consists of. So sure. Concrete consists of gravel and sand, cement, water and some additives. Yeah. It's the cement in the concrete aggregate that is reacting with the CO2. When we now reuse concrete aggregate for the production of recycling concrete, the concrete aggregate is substituting the primary material, gravel and sand. And we performed many material tests also with EMPA here in Switzerland.
EMPA, that's the Swiss Federal Laboratories for Materials Science and Technology near Zurich.
And these material tests could show that the reactivity of the concrete aggregate is increased by carbonating it with CO2.
So it becomes tougher? Or?
Yeah, if it's then reused for the production of new concrete, it can increase the compressive strength of the concrete, and this can lead to the fact that we can reduce the cement content in the concrete.
So that's better for the environment, right?
Exactly. So additionally to storing CO2, we can also, with some of our partners, reduce the cement content and then reduce further emissions from cement production.
Okay.
Lisa then took me through the facility where the carbonising happens. It consists of a large stationary tank where the liquid CO2 goes in. Before it can be stored in the aggregate, the CO2 has to be turned into gas again. This process happens without extra energy inside a so-called atmospheric reboiler. That's a several metres high metal tower consisting of a system of tubes. The gas is then pumped into the container units containing the demolition waste aggregate.
You've got 3 of these units, and they're storing the pieces of concrete that have been broken up from the paper plants, right?
Exactly.
Yeah, okay.
So the material is filled in from the top.
Yep.
Each of these units encompasses 50 cubic meters. Then the flap is closed and the CO2 is injected from the bottom.
And what's the chemical process that's going on inside each unit when it's when the CO2 is mixed with the concrete?
The process that is happening is called mineralisation. It's a chemical process. Essentially, it's the old cement in the concrete aggregate that is reacting with the CO2. And this leads then to the conversion of the CO2 to limestone.
Limestone, okay.
Exactly. So
which is a very, very permanent...
It's the most durable form of CO2 storage.
Okay. And what are the advantages of your technology?
The advantage is that we can store CO2 durably, so for thousands of years in a very, very short time. So to give you a comparison, this facility can store in 1 hour as much as 50 trees in a year.
Right, okay. But it's expensive though, isn't it?
Well, it's more expensive than planting a tree for sure.
Okay.
But if you look at the durability of CO2 storage, so with a tree, the CO2 can be easily re-emitted due to wildfires, but also at the decay process, natural decay process of a tree.
How does your technology, your carbon storage technology compare with other techniques?
I mean, maybe beforehand, the world will need approximately 6 to 10 billion tons of CDR per year by 2050. So giant amounts. It's approximately a quarter of what we emit today as a world. So there is not the one solution that will solve this problem, but we need a variety of different solutions. So we will need reforestation, we will need biochar, we will need direct air capture, and we will also need enhanced mineralization, how we are performing it here.
Okay.
The concrete produced here in Biberist will be used for new buildings in the region and for road construction.
Switzerland is quite a pioneer in the production of recycling concrete. So in Switzerland, approximately 50% of the demolition concrete ends up again in the production of new concrete. The remaining is then going into road construction. Outside of Switzerland, this looks quite differently. So in other European countries, Germany, France, for example, the vast majority of demolition concrete ends up in road construction as a filler material.
Currently, Neustark is running 21 capture and storage sites in Switzerland and abroad. The demolition waste needed, so Lisa tells me, will not cease anytime soon.
What is expected is the amount of demolition concrete will double every 10 years. The reason for that is that we built much more with concrete after the Second World War, and all these buildings will be teared down in 50 to 100 years eventually. And this is why we expect that we will be able to store much more CO2 2050 than today.
In 2023, Neustark, the spin-off from the Federal Technology Institute, ETH Zurich, signed a partnership deal with the cement giant Holcim. It committed it to rolling out the innovative CO2 storage tech at its sites worldwide.
You're expanding rapidly. You've got a partnership with Holcim. I saw some deals with Microsoft. I mean, it's impressive growth. Can you tell me a little bit about what your ambitions are, bigger ambitions of the company?
We have quite big ambitions. So our main target that we have as a company is to remove 1 million ton of CO2 per year by 2030. So this means we have to build many more of such storage facilities as we have here in many different countries, so that we can reach as much mineral waste as possible.
What's been sort of holding you back? Is it demand, or is it, the high cost of this technology?
I would say there are different factors. On one side, of course, demand. So the end product that we are producing here are carbon dioxide removal certificates, which are bought by companies that have ambitious net zero targets, such as Microsoft, for example. However, today the market is still very small. For example, Zurich has a net zero target for 2040. So
They're really behind you, right?
Yes, they are really behind us, and we are important solutions for them as well to achieve these targets, right? So that's also another incentive that our partners have, that local institutions like Zurich are tendering carbonated concrete aggregate. And this, of course, if you want to apply to this tendering, you will need our solution to do so. I mean, Switzerland is quite advanced. Also, they are very aware that we will need carbon dioxide removal for the Swiss climate target of 2050, so to achieve net zero in 2050. And the Swiss government is really supporting solutions like ours and wants to help us scale.
Thank you, Simon. You visited that site in Solothurn where you spoke to Lisa Brown in the summer. Have there been any new developments since?
Definitely. The company is enjoying great success at the moment. It's secured huge funding for its initiatives. And among the carbon capture and removal sites, we've seen quite a number of new developments. There's been a first site announced in the UK, in Greenwich, introducing the carbon removal technology. And also in Switzerland, the first CO2 capture site has been introduced in Geneva, in French-speaking Switzerland. And Neustark is also working on a pioneering carbon capture and storage site in Zurich for 2028.
OK, so lots of exciting developments happening at home and abroad in that case. Thank you very much, Simon.
You're welcome.
You can find more on this and other CO2 capturing and storage projects on our website, swissinfo.ch. And if you like what you heard today, leave us a 5-star review where you get your podcasts. Coming up in our next episode, we're talking about global warming and heat waves. Hot summers might seem like a little bit of a distant memory right now, but it's an urgent problem that's not going away. And in some parts of the world, city dwellers are really hard hit. Luigi Horio talks to an expert at the Federal Technology Institute, ETH Zurich, about this. Today's episode was recorded and edited by our science and video journalist Michele Andina. For more content, visit our website swissinfo.ch. I'm Jo Fay. Thanks for listening.
Hello, I'm Imogen Folks from Swiss Info's Inside Geneva podcast. On February 24th, 2022, Russia attacked Ukraine. The invasion caused Europe's largest refugee crisis since World War II, and during the year-long conflict, tens of thousands, possibly hundreds of thousands of people, soldiers and civilians, have been killed. Over the past year, a number of episodes of Inside Geneva have looked at the heavy humanitarian toll of the war and its wider implications for the world. We've been joined by historians and international human rights experts to ask about the background to the invasion. We've talked to major UN aid agencies about how the war in Ukraine is impacting other humanitarian crises. And we've asked if sanctions or war crimes investigations can stop or at least limit this conflict. If you're particularly concerned by the war in Ukraine, do listen to these episodes. You can find Inside Geneva free to listen on Apple Podcasts, Spotify, Google, and all your usual podcast apps.